Hello, fellow colleagues. I represent the Laboratory of Theoretical Physics of the Institute of High Current Electronics, and the report is devoted to the theoretical simulation of negative coronal discharge. About trichel pulses. Trichel pulses is an interesting phenomenon with regular current pulses existing in negative coronal discharge. A lot of researchers have investigated the characteristics of current pulses, and the physical mechanism of current pulses is basically clear. On the other hand, a lot of research is focused to the mechanism of a transition from the current pulses mode to a stationary discharge. They proposed different factors affecting the transition, such as gas heating, external circuit, and excited spaces. And at the moment, there's no clear opinion. That is why we have chosen to study a transition for the trichel pulses mode to a stationary discharge, and as a result, we get a multi-fluid model of negative current discharge describing the transition. And now let's move to the model description. We use a hydrodynamic approach. Electron components are described by the two-moment continuity equations, equations for number density and energy density. With a Drake diffusion approximation, hydrodynamic fluxes, the transport coefficients in the hydrodynamic fluxes, such as mobility and diffusivity, are calculated using the Baltic plus two-term Boltzmann equation solver. The heavy species include ions and neutral species, described by mass continuity equations. The diffusion coefficients are calculated using mixture average diffusion model, and the rate expression and rate coefficient for electrons are determined by plasma chemistry, as will be discussed later. The continuity equations are coupled to the Poisson's equations consistently, and global variables such as discharge current, voltage are determined by these formulas. Our real three-dimensional configurations was substituted by a two-dimensional axis symmetric domain. A source voltage, which varies in this range, is applied to a needle with a small radius of curvature, and at the electrode distance is plane anode, grounded anode. The theoretical model is implemented in the plasma model of COMSOL multiphysics. As initial conditions, we took a uniform quasi-neutral plasma, and we included also field emission and secondary emission. Now, and you can see the finite element mesh, what we used in this model. And what about the set is based on this paper. We added also impact association, and the impactization cross-section are calculated using Baltic plus over 2. Is electron impact reactions, and heavy species reactions are included recharge, detachment, and recombination, and production of O4+. And we included included 9 ions particles, include O4 plus ions, O2 minus ions, and the others. Now let's move to the result. Now you can see the all trichel pulses in time. It's about 100 pulses. The first pulse is 2 times, the amplitude of first pulses is 2-3 times larger than the amplitude of subsequent pulses. The repetition rate increases in time. The amplitude decreases in time too. At the end of trichel pulses sequence, you can see the 3 pulses decreases and transition to a stationary current. What goes next? Here makes a smooth transition to the stationary discharge. You can see the smooth current decreases and breakdown process. And if we increase this applied voltage in 2 times, you can see the number of pulses exponentially decreases. Amplitude of first pulse is also larger than the amplitude of subsequent pulses too. Repetition rate is increases and pulses disappears and makes a smooth transition too. The time duration time channel formation time is exponentially decreases as the voltage increased. And what's about the plasma? Now you can see the main plasma component: electrons, negative ions O2 minus and positive ions O4 plus, and electric field strength at different time points during the one current pulse. Now you can see the space charge separation occurs. In the middle, you can see the positive space charge consisting mainly of four classes, and negative space charge away from the needle. And then, when the electrons are produced due to the ionization process and elimination, electrons are produced, and the positive space charge are compensated with the tube. Then this positive space charge is compensated. You can see the electrons attached to the molecules. Negative space charge occurs and current increases with time. Attachment process is continuous. Then you can see current increases, and then continues the recombination process and the detachment process. And this leading to the removal of negative space charge from the needle, the space charge moving from the needle towards the anode, and current decrease. Now you can see that the conditions of electric field and number density restores, and it's prepared to a new current pulse. Now, after the plasma during the trichel pulses sequence has filled the diode and reached anode, the trichel pulse sequences builds up a plasma background between electrodes, which leads to the formation of plasma channel. Now you can see all these figures. And here you can see the duration of discharge evolution stages at light voltage. Now you can see the duration, trichel mode, and channel formation time are exponentially decreases as the applied voltage increased. And now, final, you can see the conclusions. The evolution of carbonic discharge at constant voltage value includes two
More louder, please.
Includes two stages: a transition, a trichel pulses mode, and a transition to the stationary globe discharge. Pulse period mode is caused by the presence of negative ions. Negative ions suppress the electric field near the tip. Trichel pulses sequence over time builds up a plasma background, which leads to the formation of a stationary discharge. And the duration of trichel pulses mode gradually decreases with increases of applied voltage. And this stage practically disappears at a voltage of 100 kilovolts. That's all. Thank you for your attention.
Questions, please? Thank you for your presentation. My question is following. Why do you use the equation for electron energy? Does you use the equation of balance, equation of movement, and equation of energy, but you also solved the Boltzmann equation. If you solved the Boltzmann equation, it's not necessary to solve the equation for electron energy, because the electron energy is determined by solving the Boltzmann equation in the local approach. And the local approach is applicable for atmospheric pressure. But in the cases, if the local approach is not applicated, you have to solve the Boltzmann equation in energy and coordinate approximation. Only Boltzmann equation, not balance equation of energy and whole, but the Boltzmann equation in for coordinates and energies. The balance equation for energy is not necessary.
Okay.
No, previous.
Oh,
This. In right side equation.
we don't use Boltzmann equation to calculate transport, plasma transport and gas diet. We use Boltzmann equation only to determine the coefficient, transport coefficient, mobility and diffusivity,
Yes.
in two-term approximation. Two-term approximation. Only to define this parameters, mobility and diffusivity.
But if you obtain the electron energy distribution function as a result of solving the Boltzmann equation, you can determine all interesting, all kinetic parameters, mobility, ionization coefficients, and so on. And why we use this right equation? What you determine
We
with the
use
help of this?
hydrodynamic approach. We describe plasma as some liquids, not using the distribution function. Because the distribution functions will have 5 dimensions, at least. Two coordinates, two coordinates of energies and time. We don't use it. If
Yes, the well-known approach of modeling is the solving the Boltzmann equation only for energy, because the electron energy distribution, the characteristic scale of energy distribution functions of estimation of energy distribution function is several orders smaller than the character scale of your problem. It's main used approach for modeling the atmospheric discharges. And if in most cases this approach is applicable, but in the cases when this approach is not applicable in some cases, you have to solve Boltzmann equation in 5 coordinates and not another.
I understand that the solving Boltzmann equation has an assumption, but in this case the assumption is applicable. We can use, and there are many papers who do this.
Well, let's discuss after the
Okay.
section.
Okay.
This show many pulses. Calculation from trichel it's okay. In this way is voltage.
It's a black.
Black. If voltage will be constant, you observe the transition from trichel mode to continuous mode.
In this case, apply voltage constant. Electric circle has capacitance.
Increase for this level, and here voltage will be constant. Trichel mode continuous or come to constant.
This voltage is increases because it has capacity. But applied voltage is constant. If don't use the capacity, you can see the pulses, but the shapes was
Will be same amplitude.
yeah.
Thank you. More questions?
Is it possible then to compensate the applied voltage to make the voltage shown here constant, or at least more constant?
Yeah. If we don't include the capacity in the model. As you can see, discharge voltage are calculated. Use the capacitors and resistance. If this term is disabled, then yes, you can see the constant stage, and then the breakdown occurs. You can see the.
Okay, a small question. I didn't catch one thing.
I didn't catch one thing. You said that trichel pulses is a feature of negative corona. Do trichel pulses in positive corona exist?
Pulse periodic
Oh.
mode and positive coronal discharge exist. But the trichel, original paper of trichel, he describes as I know, only negative coronal discharge.
Okay.
It's a test question, yeah?
No.
Why the first pulses, value of first pulses is larger than the values of other pulses? Is this phenomena a physical phenomenon connected with some physical processes, or is this phenomena caused by calculation, maybe by initial conditions or other reason?
I get it. The first pulse, there are many experimental studies who confirm that the first current pulse is much larger than the subsequent pulses. But, our model, why first pulses are larger, is because initial plasma distributions before first pulses is practically uniform. It appears ionization process at the before the first pulses. Plasma distributions has non-uniform distributions because the ionization process occurs at the needle. And when the first pulses occurs, you can see such plasma distributions. Before first pulses, the distributions is not like that. It's not uniform plus non-uniform distributions of electrons and ions.
No questions? This.
You've mentioned that you're using console software to model this, and could you tell how well is it suited for modeling such tasks? Have you had any problems with conversions or something else?
At the start, we have problems, but in time, we know how to fix these instabilities and so on. Console has many tools which can suppress, decrease instabilities and increase the conversions.
Could you please give an example?
Source stabilization, for example. Additional source stabilization, additional term for the rate expression in logarithmic as a logarithmic function. And if number density of heavy species or electron are near to zero, this addition will compensate this, and there's no problem with this. For example, stabilization source.
Okay, thank you.